Hey everyone, Mr. Kimsing here, and some just last minute revision of how I solve any trig identities question. So here's some key things you want to think about. First of all, you want to be really familiar with your identities. So the Pythagorean ones and also the, I guess I call them definitions, right? So things like sine squared plus cos squared theta is equal to 1. So that's actually on your formula sheet. Now these next ones aren't on your formula sheet. Thankfully there are some good sort of mnemonics and little tricks that you can remember. So one of them is 1 and 10 is a secret. The few other versions of that one as well though. So that means that it's a sec squared theta there. Another way you can actually do this is if you look at this guy over here, if you divide everything over here by, I'm just going to have to remember this one, cos squared theta, you can actually derive to this one over here. So if you divide by cos squared theta, and you just rearrange that left side a little bit, you'll get to this one. And certainly for this one, 1 and a cot is cozy, so that's cosec squared theta. Okay. And so you can see that if we take that, that's another way you can remember that. Otherwise, if you want to divide again, you can see if you divide this one by, looks like sine squared theta from memory. Yep. So if you divide by sine squared theta, so let me write it that way, divide by sine squared theta, you can also derive that one there. So since this was on your formula sheet, you don't have to memorize that one, but these two you can get through either the mnemonics or by dividing. These ones here, we have our definition, tan theta is equal to sine theta on cos theta, something that often is forgotten. It's actually very useful, as you'll see in these couple of questions, but also our reciprocal ratios. And the trick is the third letter there represents which one the ratio corresponds to. So that's 1 over sine theta, this is 1 over cos theta, and this one's 1 over tan theta, okay? So these are the things to get us rolling. And I wouldn't say necessarily that any question is easy after this, but at least you know the tools that are available that you can use, because typically they will involve one of these kind of things. So let's look at this one, for example. Prove that cos theta is equal to tan theta is equal to sine theta. And so the first thing you want to think about is, what are my options here? If there are no sort of squaring options, then I typically discount the Pythagorean ones for now at least, and I look towards my definitions. So I can see that, well, cos theta and sine theta, they don't really have definitions, but tan theta has another definition as sine theta and cos theta, right? So we might as well just try that. Now, in terms of whether you want to start with LHS or RHS, almost always, it seems like they want people to start with LHS, but that's not always the case. So just be careful about that. The thing that I look for is, what can I do more with? For example, sine theta, there's not much you can do with that, right? That's just there, right? Whereas tan theta, you can rewrite in a different way. So the thing that's more complicated usually has more options in terms of what you can do. So let's look at LHS. That's going to be cos theta times, instead of tan theta, well, I'll write tan theta first, maybe since I'm writing the first statement, but then instead of tan theta, I'm going to now write sine theta and cos theta. And you can see actually that's quite nice. These will just divide through, and you get left with sine theta, which is equal to the right-hand side over there. Right? So you can see, just by looking at the definitions that you have here, you open up some avenues in terms of where we can go with this proof. All right, let's have a look at this guy. So now we've got some brackets, sec theta plus tan theta outside of sec theta minus tan theta, and that's equal to 1. And again, same idea. Well, the RHS isn't looking crash hot because, I mean, 1, well, 1 is what? 2 minus 1, right? There's not much you can do with that. So I'll tend to look towards the left-hand side for this one. And so when I'm going to be thinking about options here, what can we do? Well, since there's brackets, I can expand, just like you would with the quadratic. Don't be fazed by the fact that it's trigonometric ratios here. We can still use our expansion rules, right? So FOIL first, outside, inside, last. So I've got sec theta times sec theta, which is sec squared theta. I've got sec theta times negative tan theta. I've got tan theta times sec theta. And my last one, I've got, what have we got? Tan theta and tan theta, so minus tan squared theta, okay? And you can see these two, that's just multiplication, so that order doesn't matter there, so I can just cancel those out because it's subtracting and addition. And so I get left with sec squared theta minus tan squared theta. Now somehow I'm going to get 1 from all of this. So if you have a look over the left here, see if there's anything we can use. Because I've got squares, I'm looking towards my Pythagorean identities now. So let's have a look towards that. I think the easiest one would be to change this to 1 plus tan squared theta. So 1 plus tan squared theta, take away tan squared theta, and hey, lo and behold, that's quite nice, isn't it? These two again, we just cancel through, and we get left with 1, which is equal to RHS as required, right? So you can see the little tricks I'm looking for now. If there's a square there, I want to look towards my Pythagorean identity, see if there's any options here. All right, last one, a little bit of a doozy. And again here, it's a bit more unclear which one do we start with, because it seems like there's both things we do. For example, cot squared is 1 on tan squared, and sine squared is, well, I could rearrange this side, for example, to write it in a different way. But again, when I'm comparing these two options, typically it's harder to go from something that doesn't have a fraction to something which does have a fraction. So if there's something that has a fraction, I tend to start with that one just because there are things I can do with that. For example, I could split them up. Or if they were separate already, I could put them under a common denominator. I feel like there's still more options though, even though there's things you can do with both sides. Honestly though, it's just a bit of experience and a bit of experimenting. If you try something and it doesn't work, that's okay. Try something else, backtrack a little bit and see where that takes you. So let's start with the left-hand side in this one. 1 minus sine squared theta cos squared theta all over sine squared theta, right? And, well, I can't, I mean, they're already under a common denominator. I could split them up. So, might want to try that. Let's split it up. So I've got 1 on sine squared theta minus sine squared theta cos squared theta all over sine squared theta. I really hope this is going to take me somewhere. 1 on sine squared theta is the same as cosec squared theta. And, oh, this is kind of nice, it divides through, so it's cos squared theta. So at this point, this is where you kind of want to reevaluate. You want to be, what's the goal of what I'm actually trying to do? What's the purpose of all of this? I'm trying to get to this. Is this looking like this? Is it helping? These are the questions you want to reflect on as you're going through the proof. And although these don't resemble these, what you want to try and think about is there a relationship between these and these? And what we do know is, for example, cosec squared theta is 1 plus cot squared theta, right? And cos squared theta, there's no identity for that, but this guy over here, we can actually rearrange him, and he can become cos squared theta is equal to, if you just take the sine squared to the other side, so 1 minus sine squared theta over here, well, that's actually useful because that introduces sine squared theta. So you can see how I'm thinking about these things along the way as I go. I do want to just try something, but I also want to try something with a bit of purpose as well. So cosec squared theta, I'm going to rewrite in terms of that. So it's 1 plus cot squared theta. And cosec squared theta, sorry, that's what I just did. And cos squared theta now, I can rewrite as, now be careful of the minus here, so it's 1 minus sine squared theta. Cool. And hey, that's actually not too bad because what we end up with is 1 plus cot squared theta, take away 1 plus sine squared theta. And these will cancel out. And so actually I get left with cot squared theta plus sine squared theta, which is the right-hand side. So hopefully this is just giving you a little snapshot of what are the options you have. These are the key things you need to know. And these are a few different types of problems that we use. Here's one using definitions. Here's one using the Pythagorean identity. And here's one that kind of combines them a little bit together as well. So hopefully that helps and gives you an idea of what to do to solve any trig identities question.